Welcome to yet another series of episodes on our YouTube channel, Mathematics and Statistics, which we call MAST or MUST. In this series of episodes, we will be discussing about calculus, more specifically integration, and we will be solving 100 integration sums from different subtopics of integration to help you prepare for your board exams. Integration sec x by sec x plus tan x. Integration sec x by sec x plus tan x. We are rationalizing the denominator. So we are multiplying by sec x minus tan x. So we have integration sec square x minus sec x tan x whole divided by sec square x minus tan square x dx, which can be written as integration sec square x minus sec x tan x, because sec square x minus tan square x is 1, which can further be written as integration sec square x dx minus integration sec x tan x dx, which will be tan x minus sec x plus c. Integration tan inverse root over 1 minus sin x by 1 plus sin x. Integration tan inverse root over 1 minus cos pi by 2 minus x by 1 plus cos pi by 2 minus x dx, which can further be written as tan inverse root over 2 sin square pi by 4 minus x by 2 by 2 cos square pi by 4 minus x by 2 dx, using the formula for 1 minus cos theta as 2 sin square theta by 2. So this will be further simplified as tan pi by 4 minus x by 2 dx, which can be written as integration of pi by 4 minus x by 2 dx, which will be pi by 4 into x minus x square by 4 plus c. Integration root over 1 plus x by 1 minus x dx. Integration 1 plus x by 1 minus x, rationalizing the denominator. So multiplying by root over 1 plus x, both the numerator and denominator, we will have 1 plus x by root over 1 minus x square dx, which can be written as integration 1 by root over 1 minus x square dx plus integration x dx by root over 1 minus x square. So this can be written as sin inverse x plus integration x dx by root over 1 minus x square. Let 1 minus x square equals to t implies minus 2x dx equals to dt implies x dx equals to minus dt by 2. So this can be written as sin inverse x plus integration half outside minus dt by root t, which is sine inverse x minus 1 by t integration t to the power minus half dt, which will be sine inverse x minus half t to the power half by half plus c, which will be sine inverse minus t to the power half plus c, which will be sine inverse x minus 1 minus x square in root plus c. Integration 1 plus sine x divided by 1 plus cos x dx. So this can be written as integration 1 by 1 plus cos x dx plus integration sin x dx by 1 plus cos x. This can be written as 1 by 2 integration dx by cos square x by 2. Why? Because 1 plus cos x is 2 cos square x by 2. I have taken the 2 outside. So I have got integration dx by cos square x by 2 plus integration sin x by 1 plus cos x dx. So this can be written as 1 by 2 integration sec square x by 2 dx, and in this we will substitute let 1 plus cos x equals to t, so minus sin x dx equals to dt implies sin x dx equals to minus dt. So we will have integration dt by t. So we will have 1 by 2 integration of sec square x by 2 will become tan x by 2 by half minus log mod t plus c, which will be tan x by 2 minus log mod t would be 1 plus cos x plus c. Integration dx by root over ax plus b plus root over ax minus b. Dx by root over ax plus b plus root over ax minus b, we are rationalizing, so ax plus b minus ax minus b both in root by root over ax plus b minus root over ax minus b. So we will have ax plus b minus ax minus b in brackets dx by a plus b into a minus b. So we will have ax plus b minus ax minus b. So we will have 1 by 2b integration root over ax plus b minus root over ax minus b dx, which can be further simplified into 1 by 2b integration root ax plus b dx minus 1 by 2b integration root ax minus b dx. Now we are naming this as integration 1 and this as integration 2. Let us solve I1. I1 is equals to 1 by 2b integration root ax plus b dx. Let ax plus b equals to z square implies a dx equals to 2z dz implies dx equals to 2z dz by a. So we will have 1 by 2b integration for a root ax plus b we write z, and for dx we write 2z dz by a. So we will have 1 by 2ab integration 2z square dz. So this will come out as z cube by 3ab. This will be the value for I1. Now moving on to I2. I2 would be 1 by 2b integration root ax minus b dx. Similarly, let ax minus b equals to u square. So we have ax minus b equals to u square implies a dx equals to 2u du implies dx is 2u by a du. So we have 1 by 2b integration u into 2u by a du, which can be written as 1 by 2ab integration 2u square du, which can be written as u cube by 3ab. So my final result will be z cube by 3ab minus u cube by 3ab plus c, which can be further written as ax plus b to the power 3 by 2 by 3ab minus ax minus b to the power 3 by 2 by 3ab plus c. Integration dx by root over e to the power x minus 1. In this sum, let e to the power x equals to sec square theta implies e to the power x dx equals to 2 sec theta into sec theta tan theta d theta implies dx is equals to 2 sec square theta into tan theta d theta by sec square theta, which will be 2 tan theta d theta. Now substituting here, we will have 2 tan theta by root over sec square theta minus 1 d theta, which will be 2 integration d theta, because here you will have tan theta, in the denominator also you will have tan theta, which will cancel to give you 2 integration of d theta, which will be 2 theta plus c. Now since we have taken e to the power x equals to sec square theta implies sec theta equals to root over of e to the power x implies theta equals to sec inverse root over e to the power x. So this can be written as 2 into sec inverse root over of e to the power x plus c. Integration root over tan x by sin 2x dx. So we can write this as integration root over tan x by sin 2x can be written as 2 sin x cos x dx. Now dividing the numerator and denominator by cos square x. So you will have root tan x into sec square x by 2 tan x. Then let tan x equals to theta square implies sec square x dx equals to 2 theta d theta, which makes it tan x equals to theta square. So root tan x will be theta. Sec square x dx will give you 2 theta d theta by 2 theta square, which will be integration of d theta, which will be theta plus c, which will give us tan x equals to theta square. So theta equals to root tan x. So you will have the answer as root tan x plus c. Integration e to the power x minus 1 by e to the power x plus 1 dx. Multiplying numerator and denominator by e to the power minus x by 2. So in the numerator we have e to the power minus x by 2 into e to the power x minus 1 dx. In the denominator we will have e to the power minus x by 2 e to the power x plus 1. So we will have e to the power x by 2 minus e to the power minus x by 2 by e to the power x by 2 plus e to the power minus x by 2 dx. Let e to the power x by 2 plus e to the power minus x by 2 equals to t. So we will have half e to the power x by 2 minus e to the power minus x by 2 dx equals to dt, or e to the power x by 2 minus e to the power minus x by 2 dx equals to 2 dt. So from here we can write, so this will effectively become integration 2 dt by t, which will be 2 integration dt by t, which will be 2 log mod t plus c. So we have 2 log mod t plus c, which can be written as 2 log mod e to the power x by 2 plus e to the power minus x by 2 plus c. Moving on to sum number 9, integration root x by a minus x dx. Let x equals to a sine square theta implies dx equals to 2a sine theta cos theta d theta. So we will have integration root over a sine square theta by a minus a sine square theta into 2a sine theta cos theta d theta. So we'll have integration a sine square theta, I take a common, 1 minus sine square theta into 2a sine theta cos theta d theta, which will be integration tan theta into 2a sine theta cos theta d theta, which will be 2a integration sine square theta d theta. This can also be written as a integration 2 sine square theta d theta, which is a integration 1 minus cos 2 theta d theta. So after integration, we get a integration 1 d theta So after integration, we get a theta minus a sine 2 theta by 2 plus c, which is a theta minus 2a sin theta cos theta by 2 plus c, which is a theta minus a sin theta cos theta plus c. Now we have taken x equals to a sin square theta, implies sin square theta equals to x by a, implies sin theta equals to root over of x by a, implies theta will be sin inverse root over x by a. So if I substitute it in this equation, I'll get a sin inverse root over x by a minus root over x into a minus x plus c, which will be the answer. Sum number 10, integration dx by a sin x plus b cos x. Let a equals to r cos theta, b equals to r sin theta, implies a square equals to r square cos square theta, b square equals to r square sin square theta, implies r square equals to a square plus b square, implies r equals to root over a square plus b square. If I consider this as equation 1 and this is equation 2, I get tan theta equals to b by a, implies theta equals to tan inverse b by a. So my integration becomes dx by r cos theta sin x plus r sin theta cos x. So by taking r common outside, dx by sin x plus theta, which can be written as 1 by r integration cosec x plus theta dx. So the integration of cosec is log tan x by 2 plus c. Now what is the value of r? We have got the value of r as root over a square plus b square. Then we have log tan x by 2, I'll keep as x by 2, and I'll replace theta by 2 as 1 by 2 tan inverse b by a plus c. Moving on to sum number 11, integration sin inverse 1 by x dx. Now integration sin inverse 1 by x dx can be written as integration cosec inverse x dx. So since there is one function, we take it as integration cosec inverse x into 1 dx. So using integration by parts, we will have cosec inverse x integration of dx minus integration of differentiation of cosec inverse x into integration of dx, which will be cosec inverse x into x minus integration of the differentiation of cosec inverse x is 1 by x into root over x square minus 1 into integration of x dx will be x dx. So we will have x cosec inverse x minus integration of 1 by root over x square minus 1 dx, which will be x cosec inverse x minus log mod x plus root over x square minus 1 plus c. Sum number 12. Integration x plus cos x by 1 minus sin x dx. We can write this as integration x by 1 minus sin x dx plus integration cos x by 1 minus sin x dx. So, rationalizing, we have x into 1 plus sin x by 1 minus sin square x dx plus integration cos x by 1 minus sin x dx. Integration x into 1 plus sin x by cos square x dx plus integration cos x by 1 minus sin x dx. Integration x into 1 plus sin x by cos square x dx. Rationalizing this part as well, so cos x into 1 plus sin x by 1 minus sin square x dx. So from here we will have integration x into sec square x plus sec x tan x dx plus integration of 1 plus sin x by cos x dx, taking this as I1 and this as I2, integrating I1 by parts. So x into integration of sec square x plus sec x tan x dx minus integration of differentiation of x into integration of sec square x plus sec x tan x dx. So we will have x tan x plus sec x minus integration of tan x plus sec x dx, and I2 can be written as integration of sec x plus tan x dx. So if we add I1 and I2, we will have x tan x plus sec x minus integration of tan x plus sec x dx plus integration of tan x plus sec x dx plus c, which will be x tan x plus sec x plus c. Let log x equals to z implies x equals to e to the power z implies dx equals to e to the power z dz. So my integration will become sin z into e to the power z dz. Now integrating this using integration by parts, we will have sin z integration e to the power z dz minus integration differentiation of sin z into integration of e to the power z dz. So we will have sine z into e to the power z minus integration of cos z into e to the power z dz. Now let us write this as I. So we will have, again integrating this by parts. So we will have sine z into e to the power z minus cos z being the first function, cos z into integration of e to the power z dz minus integration of differentiation of cos z into integration of e to the power z dz and integration of that. So we will have sine z into e to the power z minus cos z e to the power z minus integration of minus sine z into e to the power z dz. We have sine z into e to the power z minus cos z into e to the power z minus integration sine z into e to the power z dz, which is also incidentally my I. So we will have 2I equals to sine z into e to the power z minus cos z into e to the power z implies I equals to sine z into e to the power z minus cos z into e to the power z whole divided by 2, which is half. Now substituting sine, what was z? Z was log x into e to the power z, that means e to the power log x, which is x minus cos log x into x plus c.